We're on page 59, and these are division exercises in polynomials, and we're going to do question number 1, shown here, and then we're going to do 11 right over here, and then finally we're going to do number 20. So let's start off with number 1. And here we're asked to divide 4x squared plus 7x plus 3 by x plus 1. So we set it up like this. And we make sure that both the dividend and the divisor are written in terms of descending powers of x. So here we have the power 2. This is the power 1. And implied here is x to the 0. So 2, 1, 0 are the powers of x. Over here in the divisor, we have x to the power 1 implied, and in this term we have x to the 0. So as long as we have the descending powers in both the dividend and divisor, we can start. So what I'm going to do is take the 4x squared here, the first term here, and divide it by the first term here. So 4x squared over x gives me 4x. So that will be my first number in the quotient. So 4x here. Now I'm going to multiply 4x times x plus 1. And I do that by multiplying 4x times x gives me 4x squared. And then I multiply 4x times plus 1 here, and I get plus 4x. So 4x times x plus 1 gives me 4x squared plus 4x. So now I subtract 4x squared, and here I put a minus in front of that. So minus 4x squared gives me 0. 7x minus 4x gives me 3x. I bring down the 3, and now what I do is I take this 3x, the first term here, and divide it by x. So 3x over x is 3, and that plus 3 is the second term here. I multiply plus 3 times x plus 1 here, and 3 times x gives me 3x. And 3 times plus 1 gives me plus 3. Now I say 3x, and I subtract this 3x from it, gives me 0. 3 plus 3 here, minus 3 here gives me 0, so the remainder is 0. So when I divide, when the divisor is x plus 1, and the dividend is 4x squared plus 7x plus 3, the quotient is 4x plus 3, and the remainder is 0. So the way I can express this is to say 4x squared plus 7x plus 3 divided by x plus 1 equals 4x plus 3. So we can also look at this in another way. If we multiply both sides of this expression by x plus 1, what we get is, if we multiply this by x plus 1, then the x plus 1 in the numerator and the x plus 1 in the denominator cancel, and we're left with 4x squared plus 7x plus 3. In other words, this term here. And what we do to one side, we have to do to the other. So I have to multiply 4x3 times x plus 1. So this equation here and this one are really equivalent. Now, to verify that we do have the right answer, what I'm going to do is take the right side of this, simplify it. Take the right side of this and simplify it. So first times first, 4x times x gives me 4x squared. The outer is plus 4x. I'm using FOIL. Plus 4x. The inner is plus 3x. That's the inner. And the last times the last is plus 3 times plus 1, which gives me plus 3. I combine the inner and the outer, or outer and the inner. I combine them because they're same powers of x, x to the 1. So I get 7x. So the right side is 4x squared plus 7x plus 3. It simplifies to this. So this simplifies to that. Now if I look at the left side, then it's equal to the left side. If I didn't have the right answer to this, if this was wrong, say this side was wrong, then under my plan here of simplification, we would not get the right answer. So this is, provides a way for checking the answer. Second problem, we have to divide 3x minus x squared plus 2x cubed plus 2 by 2x plus 1. Now the first thing we do is, if we look at this, should look at this and see if it's in descending powers of x, and you can see it's not. Actually, the first 3 terms, it's in ascending powers. So I have to rearrange it so it's in descending powers. So 2x cubed is this term here. Then I do minus x squared, which is this term here, plus 3x right here, and then plus 2. The divisor is 2x plus 1. It's already in terms of decreasing powers of x. So I've rewritten the dividend in descending powers of x. And now I'm going to go through the division process. So I set it up again. Here's the divisor. Here's the dividend. And we start off by taking the first term here, right here, and dividing it by the first term here. So 2x cubed divided by 2x. There's an applied 1 here, so it's 3 minus 1 is x squared. So the first term here is x squared. So I'm going to multiply the x squared by this, and I get 2x cubed, and then I'm going to multiply the x squared by plus 1, and I get plus x squared. So x squared times this, and then x squared times this gives me this. Now I'm going to subtract 2x cubed minus 2x cubed, minus x squared minus x squared gives me minus 2x squared. I bring down the 3x. Now I'm going to take this term and divide it by the first term here. So minus 2x squared divided by 2x right here. Minus 2x squared, 2x gives me minus x. So this immediately becomes the second term in the quotient right here. Second term. The first term was obtained by dividing this by this. We got x squared. And then the second term was obtained by taking minus 2x squared and dividing it by 2x, which gives me minus x. So now I say minus x times 2x is minus 2x squared. Minus x times plus 1 gives me minus x. So this minus x times 2x plus 1 gives me minus 2x squared minus x. Now I'm going to say minus 2x squared minus 2x squared. The sum of these two on subtraction becomes 0. 3x minus minus x becomes, the minus minus becomes plus, so I get 4x. And now I'm going to bring the 2 down. And at this point, I'm going to take the first term here and divide it by the first term here. So 4x divided by 2x gives me plus 2, and that becomes this plus 2 here. So 4x minus 4x is 0, and 2 minus 2 is 0. So there's no remainder. So what we're saying is that 2x cubed minus x squared plus 3x plus 2 divided by 2x plus 1 is equal to x squared minus x plus 2. X squared minus x plus 2. So we have this right here, and the remainder is 0. So to check this, I multiply both sides by 2x plus 1. The left side just becomes the numerator here. I multiply the left side by 2x plus 1 because I want to clear the fraction. Then the left side will just equal the numerator, and the right side will equal 2x plus 1 times these three terms. So I have 2x plus 1, x squared minus x plus 1. So I'm going to take the right side of this right here, and I'm going to simplify it. So how do I do that? Well, I'm going to take 2x times all three terms in the bracket right here, and then I'm going to take plus 1, put it here, and multiply this by all three terms in the bracket. So I'm going to remove I'm going to use the distributive rule to move the brackets. So 2x times x squared gives me 2x cubed. 2x times minus x gives me minus 2x squared. And 2x times plus 2 gives me plus 4x. So now I've removed the bracket from these, and I have 1, 2, 3 terms. I'm going to remove the bracket here. 1 times x squared is x squared. Plus 1 times minus x is minus x, and plus 1 times plus 2 is plus 2. So I now have, I would expect to have 6 terms. 1, 2, 3, 4, 5, 6. Now I'm going to simplify. I'm going to collect like terms. The 2x cubed, there's only one term here, so there's no other term in x cubed. Minus 2x squared plus x squared. Those are the only two terms in x squared. Minus 2x squared plus x squared is minus x squared here. Then 4x plus 4x minus x gives me 3x. Plus 4x minus x gives me 3x. And then I have the plus 2 term. And when I check this right here, this is equal to the left side. So I started with the right side, I simplified it, and at the end it was equal to the left side. Well, the only way that could happen is if this divided by that gave me that. I'm checking whether the answer is correct. So finally, on page 59, we're going to do 2x cubed plus 5x squared minus 1 divided by x minus 2. And we rewrite the dividend so that the power of x, there's no, see, I have a power 3, I have a power 2, but I don't have the power 1. So I'm just going to write 0x here. Right here, 0x. I just got to put it in because 0 times x is 0. Now you'll see why I do this in a second. So I'm rewriting the dividend so that the x to the 1 or x has a coefficient 0. So I now have power 3, power 2, power 1 above this x, and no power of x with this number over here, 0 power. Now I'm going to divide the first term of this by the first term of that. So the first term of this by the first term of that right here, I'm showing what I'm doing, gives me 2x squared. This gives me this term 2x squared right here. Okay, now I'm going to multiply 2x squared times x, gives me 2x cubed. I'm going to multiply 2x squared minus 2x, gives me minus 4x squared. So 2x squared times x gives me 2x cubed. 2x squared times minus 2 gives me minus 4x squared. I'm going to take this, subtract this. Gives me 0. 5x squared minus 4x squared. This will become plus 4x squared on subtraction, and I get 9x squared. Now I bring the next term down, which is 0x, because this should always have descending powers of x. And I have 0 times x to the 1. So I just have 9x squared minus 0 times x, which is really 0. Now I divide this term by this term. First term here by this term. And I get 9x, which becomes the second term in my quotient. 9x squared divided by x gives me plus 9x, which is this plus 9x here. 9x times x gives me 9x squared. 9x times x gives me 9x squared, first term here, and 9x times minus 2 gives me minus 18x. So I say 9x squared minus 9x squared gives me 0 here, and 0 minus 18 gives me plus 18, and I bring the minus 1 down. So I have 18x minus 1. Now I take the first term here, 18x, and divide it by x. And so 18x divided by x gives me 18, and that's now the third number in my quotient. So when I get to this point here, I take 18x and divide it by x here. I get 18. Put that 18 up here. Now I'm going to multiply 18 times x. Gives me 18x. I'm going to multiply plus 18 times minus 2. Gives me minus 36. I'm going to subtract 18x minus 18x, so I get 0 here. And minus 1 minus 36 becomes plus 36. 36 minus 1 becomes 35. And so that is now my remainder. So if I take 2x cubed plus 5x squared minus 1 and divide it by x minus 2, the quotient is 2x squared plus 9x plus 18 with a remainder of 35. If we just look over here, right here. So this divided by this is right here. This divided by this gives me the quotient, 2x squared plus 9x plus 18 right here, but it doesn't go evenly. There is something left, remainder 35. So another way I could write this is to write this right here exactly the same. This is the same as this. This is the same as this, plus 18. And now I write my fraction as 35 over x minus 2 because that's what I'm using as my divisor. So if we multiply both sides by x minus 2, then on the left side, if I've got x minus 2 here on the numerator and x minus 2 on the denominator, they cancel. So I'm going to be left with 2x cubed plus 5x plus 1, 5x squared minus 1. So this will become this when I multiply the left side by x minus 2. Now the right side will be x minus 2, because I'm multiplying, times this whole term, plus 35, because when I take this whole thing and I multiply it, I get x minus 2 to x plus 18. But I multiply this by x minus 2, the x minus 2 on the numerator and the denominator cancel, and I'm just left with 35. Now I'm going to remove, what I'm going to do is going to take the x and multiply it by this bracket, which I do over here. Then I'm going to take the minus 2, put it here, and take the minus 2 and then multiply it by this whole bracket again. So, and then I'm going to use the distributive rule to simplify and collect like terms. X times 2x squared is 2x cubed. X times plus 9x gives me plus 9x squared. X times plus 18 gives me plus 18x. So now I've removed the first bracket. Now I'm going to multiply minus 2 times 2x squared. That gives me minus 4x squared. Minus 2 times plus 9x gives me minus 18x. And minus 2 times plus 18 gives me minus 36. And then I have the plus 35 here. So now I'm going to collect like terms. There's only one term, cubic term, that's this one. 9x squared minus 4x squared. Going to group those two together. That gives me 5x squared. 9 minus 4 gives me 5, so I get 5x squared. Now, plus 18x and minus 18x sum to 0. So I have no term in x. And then finally, minus 36 plus 35 give me minus 1. And so simplifying the right side gives me 2x cubed plus 5x squared minus 1, which is exactly what I get. 2x cubed plus 5x squared minus 1. And so the right side equals the left side, and this, therefore, this must be the right answer.